previous video of this series, you learned how to run a DCIR simulation in SI-Wave and initiate the IcePack Solver on Demand capability. In this video, you'll learn how to perform post-processing in SI-Wave and IcePack. Select Temperature in the SI-Wave Results tab and go to Display Temperature. Deselect the components on the different layers. Go to Visibility and click Temperature Plot Visibility Control. Step through the different elevations for the layers to see the hotspots. As you might expect, there is a temperature increase near the microprocessor. There are also hotspots around the voltage regulators. Under the Results tab, go to Temperature again and now select the option Open Project in IcePack. This command launches IcePack. IcePack imports the design geometry and applies the power maps from SI-Wave. Here's a 3D view of the project in ANSYS IcePack. IcePack can flag components that are operating beyond their maximum temperature limits. Exceeding these limits may cause damage to the components. Select the Power and Temperature Limit option. Input the temperature limits for the different components. These limits are obtained from the manufacturer data sheets. Enter the values as shown. After entering the values, click Apply and Accept. Go to the Post menu and select Power and Temperature Values. This command lists the calculated temperatures for each of the objects and lets you compare the values with their operating temperatures. Here, temperatures lie within the limits, predicting that the device is safe to operate. You can export this data in CSV format for further processing. You can import the CSV file into Excel and edit it as you wish. Next, display the temperature map for the board. To make all objects visible, right-click Model and select Expand All. Select the board and all the objects, including the heat sinks. Right-click and Create Object Faces Combined. This generates a temperature map on the faces of all the selected objects. If you missed any object, you can include it and update the model. So you have all of the components selected along with their heat sinks. You can see which components are getting hot and which ones are not. Click Done to close the dialog box. Now you'll create contour plots. Select Plane Cut. Enter the components of the normal vector to the plane. In this case, that's a vector in the Z direction. Select the Show Contours checkbox. Select Loop Mode. Click Create and Animate, and the cut plane will now sweep through the solution domain starting all the way from the bottom to the top. If you want, you can deselect the object face to see only the contour plot. Again, double-click Cut 1 and select Animate. This concludes part 3 of this video series. Remember that the simulation shown here assumed the board is surrounded by air that's not moving. In part 4, you will learn how to turn on airflow by specifying forced convection for the thermal simulation type, and see how that affects the results.